Alright, so for those of y'all that are online, we're doing on Schoology, I think it's quiz 7.2 or like worksheet 7.2. I'm going to do number 1 and 2 together, so let's just check and see how y'all did. So the first one here, we have the 2000 census, 80% of Americans over the age of 25 had earned a high school diploma. And we took a random sample of 120 Americans. So we have this was the census is telling us like this is like our pretty good guess at population. So like if it was the case in 2000, let's say this was like 2005, that's like our best data. So like our P is, the best guess is 80%, and we did a sample of 120. So it's just one sample of 120. Okay, so what are the mean and standard deviation? So on the formula sheet, you've got your one sample, so one p hat, and it says that the mean of that p hat is equal to the population proportion. So the mean, the average of all of those sample proportions should average out at 80%. When I do a lot of samples of 120 from America, their average is going to be 80%. Now I could get a sample that's like 82%, 78%, whatever, but the average of a lot of samples is going to be 80%. And then you can get what's your typical standard deviation, like what's the typical range to be away from there. So you do, the formula says do P times 1 minus P divided by the sample size, 120. Do the square root of that. And I got 0.0365, so you could do 7 or you could write 6.5, either way. So that's like, you have an average of 80%. If you did a ton of samples of 120 from America, the average would be 80%, but we're going to deviate from there a typical amount, like 3% plus or minus, is where a lot of our values are. So that's kind of our setup. What's the shape? So are we normally distributed or not? Or so are we like non-normal? So on these, it's n times p greater than or equal to this magic number of 10, and then the same thing, n times 1 minus p. So 120 times 80%, 20 times 20%, 96, 24. So greater than 10, so that would be like normal. So like the shape of the hypothetical all possible samples of 120 from America has a normal distribution. So like hypothetically all the possible samples of 120 of me choosing would have a normal distribution centered around 80% standard deviation, 30%. Okay. So what happens if we changed our sample size to 30? What would happen? So instead of doing a sample size of 120, now have 30. An iPad? Yeah. It still took all your computer. Just one? Yeah. This is the only one charge. Should be good. Okay.
Please pardon the interruption. Please send any 9th, 10th, or 11th graders who has not taken a picture for the yearbook with the last name A through E to room 6158 now. That's last name A through E to room 6158.
Trying to decide whose voice that is. Okay. Sample size of 30 instead of 120. So now I'm going to do a bunch of samples of 30 Americans, and what's going to be the difference? So the center, like the formula, just says that it should equal the population proportion. So our center is going to be the same at like a mean of 80%. Like the center doesn't change. So we still should have a centered of there. What's our shape? So we could check by doing 30 times 80%, 30 times 20%. I'm pretty sure it's like 24 and 6. And so 6 is less than 10. So what that means is we do not know that this is a normal distribution. So we're going to have to say that this is like non-normal or not normal, whatever. So like this shape of this hypothetical all possible samples of 30, we don't know that it's a normal distribution. It has something else. So we wouldn't be able to do our z-score calculation if we did this one. And then the spread. So what happens to the spread? And so you could do the standard deviation. So I'll tinily write it. 80% times 20% divided by 30. And I got 7%, 0.073. So what happened to the spread compared to the last one? So the spread is 7% compared to a spread of 3%. So our spread got bigger. So what happens when I do a smaller sample size? The variation gets bigger because, like, the easy example is like a sample of 2 people's heights. You can get 2 tall people, and then you get like a really big number, 2 short people, a shorter one. So the smaller the sample, the spread gets bigger. So spread increased. All right. D, you live in a small town of 500 residents over the age of 25. What's the largest possible sample you can take and still be able to calculate the standard deviation? So this is where our sample size, we want this to be like for normal, but we need our sample size to be less than 10% of our population so that we have independent samples, so that there's some room for variation. So what is 10% of 500? I believe that's 50. So you need 50 or less samples. Okay. So I don't want to be too big of a sample. So like the biggest possible sample from Bryan High is like 200 something kids, because I need to be less than 10% of 2,500 or whatever we have. Okay. So that's that first one. The second one, we're going to do a calculation. So find out what we've got. So George is a big fan of George Strait. And so 26% of his songs on his smartphone are the Beatles. Oh wait, I thought it was, no, so it's just about the Beatles. Maybe there's a different one about, is it the backside about George Strait? Maybe not. Anyways, so George sets his MP3 player to shuffle, and, or his Spotify or whatever, Apple Music, and he's gonna play on his drive. He has a sample of 50 songs. So that's how long his drive lasts. And then he's got his population on his Nano Shuffle, Apple Nano, whatever, 26%. Okay, what are the mean, standard deviation? So we've got one sample, so the mean of all the possible samples of 50 from his collection of music would be, it should average out to that 26% mark. So like, that's just where it should average out. But then there's a typical deviation of 26%, what is that, 74, right? Yeah, 74, and then over sample size of 50. And that's like 6%, 0.06. So we expect an average of like 26% of his songs are the Beatles, but could be anywhere from a lot of values are between 20 to 32 basically percent of a sample size of 50. All right. Calculate the probability that more than 30% of the 50 random songs are the Beatles. So before I do this, I need to kind of check, do we have a normal distribution, which 25% of 50 is like 12. So I think that's like 13 is what I'm going to guess. I actually didn't do it, but that's just like my number. So then that would have to be 37, I think. Let's just say that that's roughly about it. I think that's about right. Maybe it's 14, but those are bigger than 10. So what that means is I'm running out of room. That means I have a normal distribution with that mean of 26%. And then the question is, how many of these are, of the sample size of 50 songs shuffled, how many of those possible samples are 30% or more? Okay. So it's a normal distribution, got our mean, so I'm going to go to the new page. Oops. There we go. So I'm going to do a z-score of 30% minus 26%. 62. I'm going to do my value minus the mean. So value minus the mean, and then how many standard deviations. So how far am I from the mean, and then how many standard deviations is that from the mean? And you get a z-score of 0.65 standard deviations above the mean. So that means we are above average, specifically 0.65 above average. And so we've got a table of values, got like our table that can say what's a typical percentage that is above. So like you look at your table, and I just wrote the number, so that would be, let me do some mental math here. That would be like what, 7.422, I think. Right. So you look up that value of 0.65, you get that, and that's always the value that's less than. And so on our table over here, or on our value, we're looking for the above. So you go 1 minus 7.422, and you get 2.578. So about 25%. So like every time, if he gets in this car and plays 50 songs, 25% of those are going to have more than 30% Beatles played. So there's a pretty high chance that, just by chance, that he gets more than 30% Beatles songs, is what that means, out of a sample of 50. So this isn't just for like one song, it's for this sample of 50 songs that he's doing. So it gets kind of weird, and like a lot of stuff floating in the air. So like it's not just for one song, it's for this sample. It's one sample. So it gets kind of tricky when we're about to add means, and then we're going to do two sample means. You'll have two sample proportions, one sample proportion. So just nailing down, like, this is a proportion because we're talking about percentages or fractions. This is one sample because he's only doing 50 songs selected. So just getting practice and then we'll get good at them the more we do them. Okay, so that's kind of just touching base on that before we move on. So 25% chance on that. Okay, let's look at the other page, the notes page. So it says, like on the front, it has like how tall are we? It's 7.3 day 1. I'm gonna skip, and we're just gonna do like the example on the back. So we're gonna do the check your understanding and kind of just get a check of what's going on. Okay, so do I want, let's save this for Tuesday. That'll be fine. Okay, so that's what I needed. I'll pull up the formula sheet. Alright, so on our formulas, we're going to be talking about means. So this is for 1 population proportion, 2 population proportions, percentages, and then down here is our X bar, which is sample means. And so that's what we're going to do now. Like, the check your understanding is about the average amount of time people spend on YouTube. So if you're talking about averages, that's X bar. If you're talking about the percent of time someone's doing something, or the percent chance of it happening, that's percentages, that's proportions. So if it's average, it's down here. So I just want to note, like, an important thing is our formulas. So the formula, we've still got, so you've still got the, where's the average of all of the X bars? So like what this means is, like, I've got some sort of population and I'm taking a sample. So like, you don't have to write this. I'm taking a sample of 10 and there's their average. I take another sample of 10, there's their average. I take another sample of 10, there's its average. And all these X bars start to like pile up, whatever. And so their average is where the average of the means is. So the average of all of the X bars should be the population mean. Like, so this means the average of all sample means equals the population mean. Okay, so where the average of all of your all possible samples of that size, the average of all of those sample means, it should equal where your population mean is. That's the same thing. What we just did was the average of all of the sample proportions should equal your population proportion. So it's still the same idea. Like, the samples should average out. Me flipping a coin, 50% should be the average over the long haul, basically. Okay, and then the standard deviation of the sample means. So how far do we typically vary on the samples means? Is the formula sheet says take the population standard deviation and divide by the square root of n. So like, it makes sense if we do a sample, the bigger our samples get, the tighter the standard deviation gets. So that's what this is doing. It takes our population standard deviation and it divides specifically at a rate of your sample size square root. Is like by how much smaller our spreads get. So the difference between them. Okay. All right, so let's look at, let's look at an example. Oh, I have a different one. Wait, Do y'all have this one or a different one on here?
A different one.
Okay. Oops. Okay. Yeah, it's over there by the calculator. Alright. Here we go. Okay.
It's like one of those ones that's like cheap. Like one of those cheap pencils that you do always use. Oh.
Alright. I think that's right. Okay. Had an old one on there. Alright, so every day people watch 1 billion hours of videos on YouTube. That breaks down to a single person on Earth watching YouTube videos for about 8.4 minutes a day. Okay, for US teens, so let me just, I guess that was something for like our whole population. For US teens, on any given day, the amount of time spent watching YouTube is approximately normal, with a mean of 18.5, standard deviation 5.3. So that's for US teens specifically. All right. So, yeah, so on this first one, find the probability that a randomly chosen US teen watches YouTube for more than 25 minutes a day. And so in this case, this is actually like one of those normal distribution problems we did before, because how much is a sample of a randomly chosen sample? That's a sample size of like one kid. So we're just asking, like, what's the chance that if I did a sample size of 1, that kid watches more than 25 minutes in a given day? So if we wanted to go through our formulas, so like the formula, the mean of all of those sample means should be at the population mean of 18.5 minutes watched a day. Did y'all hit that mark? Wait. Oh yeah, well I know the online people are, because they watch my videos every day. Yeah. Okay, standard deviation. So let's just go through the formula that we're doing. It says take the population standard deviation, which is 5.3, and divide by the square root of your sample size, the square root of 1. So I just want to do this just to maybe be careful and not get you into a bad habit. So if you do this, the square root of 1 is 1, and you divide by 1, this is actually just 5.3. So that's because it was a sample size of 1. But it probably wouldn't be a bad habit for you to, don't always think you just use this number first. It gets tricky. So always take into account is your sample size. Because if we do a sample size of 10, like what we're going to do down below, it changes. So like, you could just take a moment to like write down the square root of 1, and then that's your standard deviation. So using our formulas. So it says that we have a normal distribution, 18.5, and what's the probability of 25 or more? Right, well, we've got a normal distribution, so we're going to put it into our standardized score, our z-score, and use our table. So I'm going to get the z-score for our 25 number. So 25 is how far from the mean, and then how many standard deviations is that? So 25 minus 18.5 divided by 5.3 is, I can't remember if I rounded or not, but I got a z-score of 1.23. So it is important. The difference between 1.22 and 1.23 is a different answer. So making sure to round that. So a z-score of 1.23. Maybe I'll just go back. So you look at your z-table, just somewhere on the formula sheet. Oops. Okay. So look at the z-score of positive, what was it? 1.23? Okay, so 1.23, 0.8907? 0.8907. So look up that value. And that value, 8907. And that is specifically that green value. So just to finish it off, I'm going to do 100% minus that 89%. So 1 minus that. And that's going to be the leftover, the greater than, which is what? 3, it's 9. Oh wow, I would have got that one wrong. 10, 9, 3. Okay. So about 10%.
So is the 8.4 just like a random piece of information?
Where is that? Oh yeah. So that's just thrown in there. Yeah. So it could have. So because you might want to look at it, because if it said like a randomly chosen person, and it might have given a standard deviation up here. But yeah, that's just kind of extra. That's just bad for us. Don't look at it. Because in the end, it just cared about the data for the U.S. team. Okay, so that's the probability for like a randomly chosen team. And then let's look at the difference between if we did a sample of 10. So suppose now we did a sample size of 10 U.S. teams.
Wouldn't it be the same?
So yeah, the mean is going to be the same, right?
Mm-hmm.
So the mean is still just, what was it, 18.5? So our average is going to be that no matter what, but standard deviation should change. So calculate and interpret standard deviation, verify that the 10%, so the 10% condition is like, is our sample size. So is choosing 10 kids less than 10% of all U.S. teams? Maybe. I mean, there's more than 100 U.S. teams in this school, so yes, we're fine. Okay, so the standard deviation, maybe let me write the formula. So standard deviation over the square root of n. So plug it in. 5.3 divided by the square root of 10. So the theory of if your sample size goes up, the spread should get smaller. And so in this case, it goes to 1.68 minutes. Okay, so it did.
Root on the bottom.
What's that?
You can have a root on the bottom of the equation.
Can't have a
I
square
know you
root.
can, but like it just looks funny.
Ah, it's just a number. In most cases, it's like a repeating number forever, but you know, it's just a number. Okay, so about 1.68 minutes. So our spread gets smaller the bigger the sample size that we do. An important thing that's always hit on, like every year. if you increase your sample size, your spread gets smaller. Okay, so that's my thing. Find the probability that the mean amount of time exceeds 25 minutes. So it's basically the same problem, but with a new standard deviation. So 18.5, 25, except, so the main thing is that we have a smaller spread. So it should change our answer. So the z-score, 25 minus 18.5, but then, like our big difference is standard deviation is no longer 5, it's like 1. So I think you do that and you get like 3.88. Did I round properly? I think. Z-score 3.8, positive 3.88.
Yes.
Oh, dang. Okay. I guess I think I used a different standard deviation. Okay, 87. My bad. Change that. So let's look up that value.
It's not on our table.
Oh yeah. Is it? Or
Oh,
ah, dang. Okay. So what you could do is like this is the smallest known value that we have. And like if you see it's like 0.996, 996, 997, 997, 997. So let's just assume like this 9998. So what that means is just a super small value anyway. So the difference is pretty small. So like we can go to the table and 0.9998. It might even be 9999. And what we can say is we can say that our answer is for sure less than 0.0002. Does that make sense? Like, we know that it's at least, it could be 001, 00009, like, it could be just a super small number. So what that means is like a super small chance of that happening in that instance. Because, and the reason why is because we're doing this increased sample size, so that should be narrowing us in on the value. So like we don't get those high outlier people anymore. Those high outliers get evened out by the low outlier stuff, and the spread zeroes in. So we have a less than that, like at least it's no greater than that for sure. So a super small chance of it happening. Okay, so pretty similar to what we've done. It's just doing means, and so identifying those is like this is talking about the average amount. The amount of time spent is a certain number, like the amount of times I wake up to my, so you can ask the same problem in a proportion or mean. Like, what's the average amount of times, I don't know, what was I thinking? Like, that I can't even.
Please pardon the interruption. Please send any 9th, 10th, or 11th graders who has not taken a yearbook picture with the last name F through J to 6158. The last names F through J to 6158.
Like this problem with the average amount of YouTube, it could be in a proportion. You could say the percent of teens watching YouTube on a daily basis is 80% of teens get on YouTube every day, or something like that. So it's just making sure, are we identifying, is it a p-hat problem or is it an x bar? So is it a sample mean or a proportion? So one of the two. Alright, so that's what I've got for us today. We're gonna continue on sample means on Tuesday. I'm gonna go ahead and hand you a paper that is not due until like next week, but you can go ahead and look at it if you want. The first problem talks about central limit theorem, which we're gonna talk about on Tuesday. So don't worry about that one.